Okay, in all our examples that we've done so far, we have used only single tables. We have not done any relationships between two entities. And what I'm going to discuss today is how we set up the entity model. And I'm going to talk about it first from the database perspective, but keep in mind that we do not make changes directly to the database when we use the model first method. We create a model that, how do I want to say it, that represents conceptually the data that we want to store. And the database is created when we do our migrations and when we update the database. I have a number of different resources online, and you should review them. Again, remember that there's only one lecture in this class, and the week is that you spend some of your time reviewing the other references. We're going to be using this tutorial, Contoso University, today and for probably a few lectures. And here is some information about it, the actual tutorial itself that talks about creating it. We also have a video that talks about one-to-many relationships, how they are represented in ASP.NET Web Core. And we also have this, which is, I think, part of the Contoso University, but I did want to highlight that. This is creating complex data models. So let's talk about our scenario here that we're going to represent. And Contoso database example has a lot of stuff in it. And some stuff is a little bit advanced, and I'm not sure if we're going to go over everything, but we're going to focus on three entities in the university here. This is meant to be an application for a university. And we're going to be interested in three of the entities for today's lecture. And those entities are courses, students, let me start over. Courses, students, and instructors. All right. Now, what are the relationships between these things? Well, course can have multiple students, and a student can be taking multiple courses. So there's a many-to-many relationship. Now, the way it's set up at this college, a course can have more than one instructor. So an instructor can teach multiple courses, and a course can be taught by multiple instructors. Okay, so that's what we have. Now, we know in database terms that we have to do something with this. We cannot implement directly a many-to-many relationship in the database. So what do we do instead? We break those down and put an intersecting entity between these two. And then create one-to-many relationships between these and the other entities. So let's make a diagram that's going to show that. So we have our courses, our students, and our instructor. We're going to create a intersecting table, because one course can have many instructors, an instructor can have many courses, and we'll call this the course instructor table. All right. This table only exists to implement that many-to-many relationship. It does not have any attributes of its own. The only attributes in it are the primary keys of the course table and the primary keys of the instructor table. And those together are the primary key of the course instructor table. Now you might say, well, we have the same thing with course and student. Well, we sort of do. But there might be some attribute. In this case, there is an attribute that we want to store that is related to a course or a student taking a particular course. We want to store their grade. All right. So we want to store the course and the student to establish that relationship, but there's an attribute beyond those keys. And that is, we also want to store the grade. Now, because of this, we're not going to call this the course student table. We're going to call this the enrollments table. And it serves the same purpose. It's going to have the primary key of both the course and the student table, and its primary key will be the combination of the course and student table. And there will also be an attribute or grade in there. So that's where we come up with the enrollments table. This is sort of the database that we want. And we're going to look at the model, how we create the model, and see if we get this relation, the structure. Let me save this. I'll save it on the desktop, and I'll call it Figure 1. Now, that's how when we look at it from a database perspective, because again, a student can't have a list of courses in a relational database table. But guess what? Our model is more conceptual. All right. Our model doesn't tie one-to-one to the database. They are equivalent representations of the same data. So in other words, if I'm defining the models here, I'm going to do something like this. I'm going to define, let's say, a student model that contains student ID, name, etc. But it's also going to contain a list of enrollments. Now, this is not a relational database table where we cannot have a list of things. This is the model where it's perfectly fine to have a list of things like that. We're going to map that model, that logical model or that conceptual model to a physical database. The enrollments, of course, are going to have student ID, course ID, and it's going to have a grade. Our course is going to have all the information about the course, but it's going to have a list of enrollments and a list of instructors. Our instructor is going to have all the things about the instructor, their name, other things, and it's going to have a list of courses. Notice that that looks very different from our database, but it is conceptually is equivalent. So in other words, when we want to look at an instructor, we're going to want to have, or in some cases at least, we're going to want to have a list of courses that they teach. when we look at a course, we want to look and see what students are enrolled in the course and what the instructors are. When we want to look at a student, we want to see the list of enrollments that they're part of, and so on. So conceptually, this is what our model is going to look like. So keep that in your head. Keep those two things in your head as we go and look at the Contoso University say that it's figure 2. And we'll actually look at the models that were created here. Now, as I mentioned before, this is a big application and there's a lot of stuff in it. And some of the stuff is a little bit advanced. So we're going to cover, at least to start with, sort of the basic stuff. All right, let's look at our models here. Let's first look at our enrollment model. That is its own entity because, again, it has attributes of its own. Its purpose doesn't exist simply to connect student and enrollment. We also are student and courses. We also want to store the grade associated with the student. So it has its own primary key. It has these two as foreign keys. Has a grade. And then associated with this enrollment is a course and a student object. So we have both the keys to the course and a student, and we also have a course and a student object. That way, when we retrieve enrollments, we can look and see what the student name is associated with that enrollment, or what the course name is associated with that enrollment. I think I neglected to put course and student in the enrollment. Maybe I was running out of space, or I didn't think of it, one of the two. So this is a conceptual model of what's associated with an enrollment. We have our enrollment ID, that's the primary key. We have course ID and student ID, which are foreign keys to their respective tables. We have a grade, and then associated with this, we have a course object that corresponds to the course ID that we have here. And we have a student object that corresponds to the student ID here. In other words, when we do a query and we retrieve enrollment data from the database, we can fill these in, and without having to write code to say, hey, we want the corresponding student or whatever. We can simply, those fields can be filled in, and we can ask for the student's last name or first name or enrollment date or any of those things. Let's look at the course model. Course model contains general information about the course, the credits. It's associated with a department ID, and it's also associated with a department object. That's what this means. And we can fill in, when we fill in and get a list of courses, we can also fill in that department and get information about the department that the course is a part of. Likewise, we can get their list of, their collection of enrollment objects and their collection of instructors objects. Let's keep this in the back of our head. This doesn't say students and instructors, it says enrollments and instructors. That's because in the case of students, there's additional information we want about that student-course relationship. That is their grade. With instructors, we only want to establish the association between courses and the instructors. If we then look at the student, we have an ID, we have a first name. We actually have a computed column for first, middle name, and something called full name, where we concatenate their last name, comma, first name, enrollment date, and then we have a collection of enrollments. Now you might look at this and say, well, isn't that redundant data? Because the enrollments has a list of students. The student has a list of enrollments. No, because this is not the way the data is stored in a database. The database will eliminate the redundancy of how it's stored. This is a representation, conceptually, a model of the data. A student has a list of enrollment records associated with them. A course has a list of enrollment records associated with them. A course also has a list of instructors associated with them. Now for instructor, notice we haven't given a name to the intersecting table like we did with enrollments, because we don't have any additional attributes associated with the relationship between instructor and courses. So where is that? How's that relationship going to get created in the actual database? Because we know from our discussion of relational databases that there has to be an intersecting entity. The answer is the model and ASP.NET Core is smart enough to figure that out. Let me indicate a few things that ASP.NET is smart enough to figure out. Let's look at the course table to start out. Course ID. It's smart enough to know that that's probably meant to be the primary key of the course table, just by virtue of the fact that it is the table name and ID. So it's going to make that the primary key of the table, which, why would we call something course ID if it wasn't the primary key of the table? So it makes assumptions. Department ID. It's smart enough to know that there's a model for department and its primary key is department ID. So it's smart enough to make a foreign key relationship between course and department. And that course has one department associated with it. So we have the department ID and we also have the department object that this course is related to. Oops. Finally, it knows that there's a relationship between enrollments and course and instructors in course. So it knows that there needs to be some kind of other table that it's related to. Now, the fact that instructors also has, as part of it, a list of courses, the model and the generation of the database is smart enough to know that that means a many-to-many relationship. And likewise, because students and courses both have a list of enrollment IDs, it's smart enough to know that this enrollment table is an intersecting table between enrollment or between course and student. So I already updated the database. Let's use SQL Server Object Explorer to look at the database. We're not going to spend a lot of time in this because remember, any changes we want to make to the model and let ASP.NET Core sync up the database to the model. But sometimes it's useful, especially when you're learning, to look at the tables that get generated. So here's our tables, the school context. All right. How did I know that? Well, we look over here at data, school context. All right, it has a course table, an instructor table that correspond to the two entities that we created for course and instructor. And it created, even though there's no course instructor entity, by virtue of the fact that in the model, course had a list of instructors, instructors had a list of courses, based on that fact, it made an intersecting table of course instructor that contains the course ID and the instructor ID. And if you notice this, that it is, these two together are the primary key, and they're both foreign keys to the respective tables. In the model, we don't define that. In the model, it's enough to say that a course has a list of instructors, instructor has a list of courses. And the model and ASP.NET, when we update our database and create that migration and update the database, it's smart enough to know, well, that means there's an intersecting table between these two. Now, again, we couldn't do that with courses and students because there's an extra attribute we want, and that is the grade. So therefore, it creates an enrollments table. And it's smart enough to make the primary key, the enrollment ID, course, student ID, and finally the grade. So let's look at that figure 1 that I stored a while ago, and let's see if we have all the tables that we thought we were going to have. We have a course table, we have a student table, we have an enrollments table, we have a course, an instructor, and we have a course instructor table. So we got pretty much what we had expected. Notice this though, let's look at the course a little closer. The course, if you remember, has an association with department, which we did not include in our initial diagram, but if we look here, it also has a department ID as a foreign key over to the department. All right, I know this might be complicated. That's why I posted a couple of references for you. Watch the video that talks about this and how those relationships are represented. So now what does that mean when we do our pages? Let's start by looking at the course page. Okay, that's a good place to start. I don't want to jump ahead into something too advanced. Let's go and run this. And this is pre-populated with data. So if I look at courses, notice what I have. I have the course number, the title of the course, how many credit hours, and the department name. All right. Now let's look to see how we can get to that. We look at our course and the model. Of course, it has the course ID, it has a title, it has number of credits. It has a department ID, and it has a department object associated with that department ID. So when we retrieve the courses, we can tell it to retrieve the department associated with this, and it will retrieve it, and then we can use the department object to pull out what we're interested, because we're not interested in department ID, we want the department name. So let's look how it pulls that. We've seen this example before. This has the extra ingredient of pulling from a related table. All right, let's look at index CSS243 and index CSS243 CS and index CSS243. Let's close these down. All right, we're going to start by looking at the code behind. This is on get, so this is when the page initially loads. All right, we don't have any post methods here because we're never going to be posting to this page. We're never going to have a form that's going to take us to this page. Or we don't have a form on this page to deal with. Okay, so let's read this. We're coming up with a list of courses, right? That's what courses is. It's associated with the model, which means that it's going to be available over here on the CSS243 page. So I want the courses to be a list of all the courses in the database, in the data context. So it's going to pull them, all the courses. Notice with this directive, though, we want to include the department in the courses. What that is telling ASP.NET Core to do is fill in this department object with the corresponding department for each particular course. We're not going to pay attention right now to some of these things as no tracking means there's no what do I want to say? No synchronization between different tasks here. We're not going to keep track to see if something's updated. And this creates a list. At some point, we'll probably talk about what async means and what await means. But essentially what this is saying is start out with this, with the list of this courses is going to be a list of courses from the database, but we're also going to fill in the department for that course. All right. So now let's look at the index.cshtml, and this will be very similar to what we had before. We're pulling the name for course ID, title, and department. That will give us those headers. For each item in model courses, so for each item in this list here, that we filled in here, we will go and we will do what? We will do something with it. So item is going to represent the individual items in that list stored in the model called courses. We're going to pull for that, and what is that going to be? It's a course item, because this is, after all, a list of courses. So I can say, give me the course ID associated with that list item. Give me the title, give me the credits, give me the item department name, right? Item is a course object. So the first few things we want are just the attributes from the course object, the title, the course ID, the credits. For department though, we want associated with that course item, associated with its department, we want the department name. And so when we run this, we get this with the department name. All right. So that's how we can combine data from two tables when we're doing a listing. We be sure that the related list in the or the related item in the query is filled in, and then we can access it using that dot notation. We want for the course, for the department of that course, we want the name of the department. Now, interesting thing, what order do these appear in? All right, what order do these appear in? Now, you might have a couple of answers, all of them reasonable, but I'm going to tell you that it's just a coincidence. And this might be the way, this might be default SQL Server behavior. But with relational databases in general, you can't count on them being in any order. Therefore, if you want them to be in a specific order, it's best to put an order by. My guess is it either puts them in order by the primary key or in the order in which they were inserted, or maybe they were inserted in the order of the primary key. I guess in general, working with databases, if you want them in a specific order, you will order them that way. So let's look up how we can put this in order. I'm Googling ASP.NET link order by. And you see a bunch of stuff. And this is what's relevant. We're going to go and we're going to say our object, order by, and then we're going to specify from that object what piece we're pulling out to order by. So let's order by department name. Now, the way this works, all right, is we're making a list and we're passing the output of the last command to the input of the next command. So this simply gives me a list of the courses. It passes it to the include, that list of courses, to the command include, which is going to fill in, is going to alter that list to fill in the department information for that course. Now we're going to pass that list that includes courses and departments here to the order by, where we can do something and order it by certain field. So I'm going to say, let's take as input the object of this list and order by department name. And isn't that wonderful how the what's that called? IntelliSense recommended that? I know for sure that that's a valid field. In the old days, when you wrote SQL statements as just a giant string that contained commands that you typed in, you had no guarantee that that column name that you put in the order by was actually in the database. All right? There was no guarantee of that. You had to make sure there was. And here, you know, by compiling, if I tried to sequence by department name, let's say, I get the red squiggly because in department, there's no attribute called department name. It's simply called name. And it's going to do this without keeping track of the records for potential updates. And it's going to create a list. It's going to take that list and it's going to put it in the iList courses. And that's what this one uses for getting a list of courses that includes department information. So let's go and let's run this again. And let's look at courses, and there they are in department name order. I guess my point is that strictly speaking, theoretically, don't count on things being in a particular order when you do a database query. Put the order by that you want, if you want an order by. Okay, let me look at one more thing, I think, today. Because this is some heavy stuff, all right? Let's look under students details. All right, student details, notice what it shows. It shows all the information about the student, and it shows a list of their enrollments. And it shows their grade. So let's take a look at that one. Notice, and I don't know if we looked at an example for this, when we click details, it passes on the query string an ID of 1. That is the ID, student ID for this particular student. I imagine this one would be 2 and this one would be 3. In the list, when it's created, it gets put on the query string so that the second page can pull it out and access the proper student. So let's look at that aspect of it too. So let's look at the student list. All right, here. This is a little bit more involved. This is one of the things that we want to be talking about immediately because this paginates students. But it's going to pull up a list of all the students in contact students, and then it's going to do some things for them. We actually have code in there to do sort them and so on. What I want to focus on in this list is how we pass to the details link ASP route ID is the item ID. So we put the item ID on the query string so details can pull it. So let's look at details. I'm going to start looking at the CS file. If there's no ID, we know that there's a problem, right? You can't access details of a student unless you say what student you want. So if there's no ID, then there's a problem. Next thing, we're pulling a list of students. All right. We are including the enrollments. What is that going to do? That's going to fill in the student model is list of enrollments for that particular student. Then include the course information. What that means is for the enrollments, we're going to fill in the course information. So if we first get the enrollments for the student, then we get the course name from the enrollment. We fill in the enrollment model this course. First or default async. This is giving us, this is selecting which one we want. We want the first, well, because it's primary key, there's only going to be one, right? The first student whose ID matches the ID that was on the query string. Notice because that onGet has the ID there, it's pulling from the query string the ID. Because it's the get async has that as an attribute. So if it doesn't find a student with that, then we get the not found error. Otherwise, we return the page and we can display it. Let's look at the detail.cshtml. Displays all the expected stuff from the student, and then it loops for each item in the student's enrollment. From the model, give me the list of students, give me each item's enrollments, and display for that the title of the course and the grade. So when we run this, we click this, it's going to pass on the query string that person's ID. It's going to retrieve their information. It's going to retrieve all the enrollment rows. And for each enrollment row, it's going to retrieve and fill in the course information. So we're able to show the course title and the grade associated with each of the enrollments for that particular student. Now, if we don't have an ID here, we get an error that that page is not found, right? Or if we have some bizarre ID, we get an error saying it's not found. We could write custom error messages to maybe give a more user-friendly response if we wanted to. But even though you might think like, well, why would someone do that? Someone just maybe playing around. We don't want to somehow do anything that might compromise the system's integrity if someone puts something, if someone types something in the URL. You know, we should test for that and make sure that nothing bad happens. Okay, a lot to absorb. Please review and revisit the resources that I have posted. We will continue looking at this example next week for some of the other outstanding features of it. Are there any questions? All right, if there are no questions, we will see you next week. Take care. Have a good one, or we'll see you in lab.